We live on a planet of astonishing surfaces. We've mapped mountains, charted continents, and tracked the paths of rivers from space. But there is another world, a hidden geography that lies not across the horizon, but beneath our feet, beneath the very waves. A world defined not by light, but by its absolute absence. Not by familiar limits, but by extremes that defy imagination. This is the deep ocean. And in its profoundest depths lies a place that stands as the ultimate geographical superlative on Earth, the Mariana Trench. Located in the western Pacific, east of the Mariana Islands, the trench is a scar on the planet's crust so deep that it could swallow Mount Everest whole and still have over a mile of water above its summit. This is a realm of crushing pressure, of eternal cold, and of a darkness so complete it has existed since long before the first creatures crawled onto land. It is not merely a hole in the ocean floor. It is a world unto itself, shaped by forces of titanic scale and inhabited by life forms that seem pulled from the pages of science fiction. Yet this is not a story of alien worlds. It is the story of our own. It is a journey to the deepest place on Earth, a place that holds the keys to our planet's violent past, its dynamic present, and the very limits of life itself. For centuries, it existed only as a theoretical line on a chart, a mystery measured by the length of a sounding line. Today, we can visit it. And what we have found there challenges everything we thought we knew about survival, about isolation, and about our own human legacy. So, let us begin a descent, layer by layer, mile by mile, from the sun-dappled surface of the Pacific into the heart of the abyss. This is the story of the Mariana Trench. To understand the trench, we must first understand that the ground beneath our feet is not static. We are standing on the fragmented, ever-shifting skin of a planet that is still cooling from its fiery birth. The Earth's crust is broken into massive, interlocking plates that float on a layer of hot, malleable rock called the mantle, and where these plates meet, the planet's most dramatic landscapes are born. The Mariana Trench exists at the convergent boundary of two such plates. Here, the Pacific Plate, the largest tectonic plate on Earth, is moving relentlessly westward. When it meets the smaller Mariana Plate, it does not stop, it begins to dive. In a process called subduction, the older, denser oceanic rock of the Pacific Plate bends and plunges downward, descending into the mantle below. This gargantuan collision in slow motion, happening at a pace no faster than the growth of your fingernails, is the engine that created and continues to deepen the trench. This is not a gentle process. It is a scene of profound geological violence, happening in absolute silence and total darkness. As the plate descends, it fractures, generating powerful earthquakes that resonate through the deep, though they are rarely felt on the surface hundreds of miles away. The friction and immense pressure melt rock, feeding magma that rises to form the arc of volcanic islands that guard the trench, the Mariana Islands themselves. The trench, therefore, is the deepest expression of the Pacific Ring of Fire. It is the lowest point in a vast horseshoe-shaped zone of subduction, volcanoes, and earthquakes that encircles the Pacific Ocean. It is a direct window into the forces that build continents, raise mountain ranges, and recycle the very ground we walk on over hundreds of millions of years. The Mariana Trench is not an ancient, dormant relic. It is an active, seething wound on the planet's crust. It is a living demonstration that the Earth is a dynamic, ever-changing world, reshaping itself from the inside out. The trench exists because deep below us, our planet is still churning, still cooling, and still writing its own geology in the language of collision and descent. Part 2. The Twilight Zone, 200 to 1,000 meters. Our descent begins in the familiar, the sunlit surface, or epipelagic zone. But we leave this world of blue and gold with startling speed. As we pass 200 meters, the light begins to change. The warm colors, the reds, oranges, and yellows, are the first to be filtered out and absorbed by the water, leaving behind a world of cool, deepening blue. This is the beginning of the mesopelagic, or the Twilight Zone. By the time we reach 1,000 meters, the transformation is nearly complete. The last traces of sunlight are a faint, ethereal blue-gray glow, insufficient to power photosynthesis. The world has become a monochrome study in shadow. The temperature has plummeted from the balmy surface to a chilly 5 degrees Celsius, and the pressure is already mounting, 100 times greater than at the surface, a steadily increasing weight that will be the defining physical reality of everything that lives below. This is where life in the deep sea begins its radical, luminous reinvention. In the fading light, true camouflage becomes impossible. Instead, many creatures have evolved a stunning alternative. They make their own light. Bioluminescence, the production and emission of light by a living organism, is the signature technology of the Twilight Zone. Look there, a lanternfish. Along its belly, rows of tiny organs called photophores emit a soft, blue-green glow. This is not a beacon to attract prey, but a cloak of invisibility. By matching the intensity and color of the faint sunlight filtering from above, it erases its own silhouette when viewed from below, a tactic called counter-illumination. It becomes a phantom, indistinguishable from the background glow. Nearby, a hatchetfish, with its body compressed into a thin metallic blade, uses a more complex array of lights to break up its outline. And then there is the vampire squid, a living fossil that seems to belong to another age. When threatened, it does not flee. It turns itself inside out, wrapping its webbed arms around its body to reveal a cloak of fearsome spines, and then ejects a cloud of bioluminescent mucus, a dazzling, confusing smokescreen of living sparks in the dark water. This zone shatters the old, monstrous myths of the deep. The 19th century artists who drew giant squid dragging ships to their doom imagined a lifeless desert below the waves. They could not have been more wrong. As the light disappears, life does not vanish. It transforms. It engineers its own stars, its own headlights, its own defense systems. The Twilight Zone is not a barren waiting room for the abyss. It is a thriving, bustling metropolis of adapted life. A city in the sky where every citizen carries its own lantern. Part 3. The Midnight Zone, 1,000 to 4,000 meters. we cross a final, invisible threshold into absolute darkness. Welcome to the bathypelagic zone, the true midnight zone. Not a single photon of sunlight has ever reached these depths. The temperature holds at a near constant, just above freezing. The silence is total, broken only by the occasional click of a shrimp or the low-frequency movement of a larger creature. But the true monarch of this realm is pressure. At 4,000 meters, the pressure is over 400 times that at the surface. It is an immense, omnipresent force, equivalent to the weight of a small car pressing on every square inch of a body. This force would instantly crush a human lung, implode a conventional submarine, and compress a hollow steel sphere into a crumpled wreck. Life here exists in a state of perpetual crushing embrace. In this world, the rules of survival are rewritten. Strength, in the muscular, skeletal sense we understand, is a liability. Hard, air-filled cavities are death sentences. Here, survival is not about power, it is about endurance. It is about being engineered from the molecular level up to withstand the crush. This is why so many creatures here appear gelatinous, delicate, almost spectral. The giant siphonophore, a colonial organism that can stretch longer than a blue whale, is a floating city of interconnected zooids, its body 95% water. Because its internal pressure matches the external pressure, it feels no strain. It is a ghostly chandelier of stinging cells, drifting through the void. The pressure-forged predators of the Midnight Zone are studies in efficient horror. The gulper eel is mostly mouth, a hinged, loosely jointed jaw that can open wide enough to swallow prey much larger than itself, which is then stored in an elastic, bag-like stomach. The fangtooth fish possesses the largest teeth relative to its body size of any marine creature, needle-like daggers that ensure any encounter with prey, however rare, is a final one. Its grotesque appearance is a direct result of the food-scarce economy of the deep. You cannot afford to let a meal escape. Even the more familiar forms are transformed. Deep sea sharks move with a slow, languid grace, their muscles softer and their livers massive with buoyant oils. Many fish have weak, watery flesh and reduced minimal skeletons. They are not built for speed or combat, but for patience and profound metabolic efficiency. In the Midnight Zone, the race goes not to the swift, but to the soft, the flexible, and the perfectly pressure-balanced. Life has been molded by the vice. Part 4. The Abyss. 4,000 to 6,000 meters. We descend further into the abyssopelagic zone. The pressure now exceeds 600 atmospheres. The landscape, when we finally see it by the glow of our lights, is one of profound alien stillness. This is the abyssal plain, a vast rolling desert of soft, oozing sediment, the accumulated marine snow of millennia. This organic detritus, the constant gentle rain of dead plankton, feces, and dust from the world above, is the foundational food source for this ecosystem. Nothing is wasted in the deep. Life here operates on a timescale of profound slowness, an energy-conserving pace dictated by scarcity. Sea cucumbers, some with feathery, branch-like appendages, crawl infinitesimally slowly, vacuuming nutrients from the ooze. Brittle stars, with arms like delicate articulated threads, sift the sediment. The tripod fish, a masterpiece of evolutionary engineering, perches on the seafloor on 3 elongated fin rays facing into the faint current, motionless for hours, waiting for a hapless crustacean to drift into its mouth. But to see the abyss as merely a silent, passive repository is to misunderstand it completely. This realm is a critical, active player in the global planetary system. The Mariana Trench, as the deepest part of the abyss, acts as a colossal sediment trap. Over eons, it collects and buries organic carbon drawn from the entire Pacific, effectively locking it away from the atmosphere. This process is a slow, deep component of the Earth's carbon cycle, influencing climate over geological time. Furthermore, the trench is a key node in the planet's great oceanic conveyor belt, the thermohaline circulation. Here, cold, dense, salty water sinks and begins its slow, centuries-long journey through the deep basins of the world's oceans. This circulation redistributes heat, oxygen, and nutrients around the globe, moderating climates and sustaining fisheries on continents thousands of miles away. The conditions shaped in the crushing quiet of the abyss ripple out to affect weather patterns, storm intensity, and even the habitability of distant shores. The core idea of the abyss is this: it is connected. Even in its profound isolation, its eternal darkness, and its crushing silence, this world is not separate. It is a deep, beating heart in the planetary system, a regulator of chemistry and climate. The trench doesn't just exist on Earth, it helps run the Earth. Part 5. Challenger Deep, 10,900 plus meters. And now, we approach the ultimate destination. The floor of the trench slopes ever downward until we reach its deepest, most profound point, Challenger Deep. 10,984 meters below the surface, nearly 7 miles straight down. Here, the pressure reaches an almost incomprehensible 1,086 bars, over 1,000 times surface pressure. It is a force that distorts the very properties of matter, where water is compressed by nearly 5%. This is the Hadal Zone, named for Hades, the ancient Greek underworld. The name is fitting. The history of human contact with this place is a short, breathtaking chronicle of engineering audacity and profound isolation. For most of history, it was a hypothetical line on a map. Then, in 1960, Swiss engineer Jacques Picard and U.S. Navy Lieutenant Don Walsh climbed into the bathyscaphe Trieste, a gasoline-filled float with a tiny, thick-walled, spherical cabin beneath it. Their descent took nearly 5 hours. At the bottom, their viewport cracked under the strain, clouding their view. They spent 20 minutes in total darkness and crushing pressure, reported seeing a flatfish, a claim later debated, and then began their 3-hour ascent. They proved it could be done. And then, for over half a century, no human returned. The void was left to itself until 2012, when filmmaker and explorer James Cameron piloted the Deepsea Challenger on a daring solo dive. His vertical torpedo of a submersible allowed him to spend hours on the bottom, collecting samples and capturing stunning solitary footage. His words upon surfacing echoed the surreal nature of the journey. It's a very lunar, very desolate place, a very alien environment. Today, a new chapter has begun with vehicles like the DSV Limiting Factor, the first commercially certified full ocean depth submersible. It has made multiple dives carrying scientists and enabling systematic exploration. Our visits are now measured in hours of bottom time, but they remain fleeting glimpses into an eternal night. So, what exists in this final frontier? Life, in defiance of all logic. Hadal amphipods, scavenging crustaceans, swim through the water column. In other trenches, they've been found to be giants, up to a foot long, a phenomenon called Hadal gigantism. Delicate, translucent sea cucumbers, nicknamed sea pigs, crawl across the sediment. Most astonishingly, in 2019, a plastic bag was documented drifting at the bottom of Challenger Deep, the ultimate symbol of human reach. The sediment itself is a treasure trove. It contains microfossils that record ancient climate shifts and microbes that thrive under pressures that would shred the proteins of surface life. These extremophiles possess enzymes and cellular structures that are of intense interest to biotechnology, from new medicines to industrial processes. Challenger Deep represents the absolute limit of our planet's geography. We have touched the bottom, but we have not comprehended it. Each sample, each image, each data point reveals how much we have yet to learn. It is the ultimate lesson in humility. We've reached the bottom, but we've barely begun to understand it. There is a profound and sobering discovery that has punctuated every recent expedition to the Hadal Zone. It is not a new species, but a starkly familiar one: our own pollution. The Mariana Trench, the most remote and extreme environment on Earth, is no longer a pristine refuge. Microplastics, tiny, fragmented pieces of our synthetic world, permeate the sediment of Challenger Deep. They have been found in the guts of the amphipods that live there. Chemical pollutants like PCBs and flame retardants, banned decades ago, persist in the ecosystem, having sunk through the water column over years to settle in this final sink. A 2019 dive by Victor Vescovo found a plastic bag and candy wrappers on the trench floor. This transforms the trench from a mere physical wonder into a profound moral mirror. It has become the ultimate archive of the Anthropocene, the geological age defined by human impact. The very forces that took tens of millions of years to create this deep scar now hold a layer of our own making, deposited in a mere blink of geological time. The contrast it presents is jarring and heartbreaking. We see the sublime alien beauty of a pressure-forged sea cucumber, a creature whose lineage may predate the dinosaurs, moving with infinite patience across the ooze. And then in the same frame, we see the synthetic, geometric gleam of a plastic shard. The two objects exist in the same space, yet they belong to entirely different worlds and tell two opposing stories. One of deep time and natural endurance, the other of fleeting human industry and carelessness. The deep ocean is resilient. It has survived asteroid impacts and planetary ice ages, but it is fragile to these novel, chemical poisons that it has no evolutionary history with, no mechanism to process. The trench shows us that there is no away. There is no place so deep, so dark, or so distant that it escapes the downstream consequences of our surface world. The core idea is inescapable and universal. Even the deepest place on Earth does not escape us. Our legacy is now written in the sediments of the abyss. The trench holds up a mirror, and in its cold, dark glass, we see the reflection of our own choices. As our submersible's lights turn away from the trench floor, and we begin the long, slow ascent back to the world of sun and wind, we are left with a profound and unresolved tension. The Mariana Trench is a place that inspires both sublime awe and deep responsibility. It stands as the definitive symbol of Earth's final frontier. Over 95% of the ocean remains unexplored, and the trench is the deepest mystery within that vast unknown. We have literally walked on the moon more times than we have visited the bottom of our own ocean. It is the greatest reminder of how little we truly know about the planet we call home. The journey through its zones is a journey through the extremes of adaptation, from the bioluminescent artists of the Twilight to the pressure-cooked survivors of the Hadal Zone. It shows us that life is not a fragile flame, but a persistent, ingenious force that will fill every conceivable niche, no matter how hostile. But this journey also forces a reckoning. We have extended our reach to this furthest point, not just with our submersibles, but with our waste. The trench is now a document of both natural wonder and human impact. So, the final reflection is this. The deepest place on Earth is not silent because it is empty. It is teeming with a slow, strange, and magnificent pulse of life that has evolved over eons in perfect harmony with its brutal world. It is silent to us because we do not stay long enough to listen. Our visits are brief, our understanding is elementary, and our presence, even as observers, leaves a trace. The trench calls back, not with a voice, but with a presence. It calls with the mystery of its unexplored vastness, with the shock of its adapted life, and with the silent accusation of our plastic in its sediments. It calls for our curiosity, yes, but more urgently, for our reverence and our restraint. It is the deepest part of our world, and in protecting it, we ultimately protect the intricate, interconnected system of which we are all a part, from the surface to the seafloor and everywhere in between.